So this next video here, student had some example problems. They wanted me to work through.
Hi, Daddy.
Hi, Drayson. Daddy's doing some math. So they had, hey, by the way, what if y equals 5 to the square root of x? You know, the first thing I would tell that student, obviously, what's the goal? What are you looking for? They said, hey, that's y, and they want to know what y prime is. You know, so for some students, maybe they're going to go, well, I think there's a shortcut. You know, as I look at that problem and I try to find y prime, I notice, oh, that exponent up here, I don't really know what to do with that. What are my derivative rules? So if I didn't have that exponent, that'd be a lot better. And I can use natural log to bring that exponent down. Another thing before we start this problem is, you know, as you look at this, realize right now you're being asked to find the derivative of a constant, a number raised to a function. So that's kind of in its own class, right? And as you do more of these, you're going to want to quickly identify, oh, hey, they're asking me to find the derivative of a number to a function. What do I do then? So we'll do that. Okay, I'm going to start by taking the natural log of both sides. So no calculus yet, you just natural logged both sides. 5 to the root x. Okay, now if you want to differentiate both sides with respect to x, you got 1 over y prime equals, well, okay, I got to differentiate the right hand side still. Square root x, natural log of 5. Sorry, I did this. I didn't want to do two things at once. So you can see I differentiated the left hand side. The right hand side, I still said, hey, you're going to take the derivative of it. But I used my properties of logarithms to rewrite this guy right here as this. Because we can differentiate that, you know, what's right here. We're just going to go ahead and notice, hey, I'm trying to find the derivative of a number times a function. Well, that's just the number times the derivative of your function. Well, the derivative of square root of x is what you got 1 over 2 root x. And, I had x to the 1/2. When I differentiate it, I got 1/2 x to the negative 1/2, which is equivalent to 1 over 2x to the 1/2, which is that thing right there. So nonetheless, you differentiate the right hand side. The left is 1 over y prime. So you're going to isolate y prime, and you got y prime equals y times natural log of 5 times 1 over 2 root x. You can substitute y back in. So back in the very beginning, y was this much. Okay, it was that function. So you can plug it in, and you got y prime equals 5 to the root x times the natural log of 5 times 1 over 2 root x. I'm looking at the student's notes here. Yeah, so you notice, like, I didn't use a formula here. I just went and used logarithmic differentiation. And if you want to do this enough times, and you're like, oh, I think I can generalize it. I've done enough problems where I'm trying to find the derivative of a number to a function. And I notice whenever I do the derivative of number to a function, it turns into this. That's fine. Just do it enough times so that you're the one coming up with the generalization. You know, otherwise it's just one more formula that's kind of going to go in one ear and out the other. Okay, next example the student asked me to do was, they said, hey, what if y is equal to log base 8 of the square root, oh, this looks nasty, of x cubed divided by 1 plus x squared. You're like, oh my goodness, how do I find y prime? First thing I would do is, logarithms are just exponents here. What this says right here is the base of 8 raised to the exponent of y. So 8 raised to the y equals the square root of x cubed over 1 plus x squared. Like, okay, so I don't think that's any easier. Well, we're all right, okay? I don't have that logarithm there anymore. I need to find y prime though. So somewhere along the way I'm going to have to find the derivative. Like, well, it's kind of inconvenient that I have this exponent. Well, what if, I know I got this natural log thing. You can always do the natural log of both sides and maintain equivalence. So natural log of 8 to the y equals natural log of, okay, square root is to the 1/2 power, right? So that's, let's see, you got x cubed over 1 plus x squared to the 1/2. So actually each side you get to use a property of logarithms. So the left side is y natural log 8. The right side is 1/2 natural log of x cubed over 1 plus x squared. Okay, so we haven't done any calculus. The goal is to find y prime. So that's no big deal. I'm going to go ahead and isolate y before I find y prime. So this is y equals, let's go with 1 over 2 natural log 8 times the natural log of x cubed over 1 plus x squared. I'm not trying to trick you. I just multiplied both sides there by 1 over natural log of 8. And then I combined this fraction with this fraction to produce this one here. So we're going to go ahead and finish this problem. My cell phone's running out of battery. We can do it though. Okay, so you got a derivative. Okay, derivative of y is y prime. That will be sweet. Okay, but the right hand side you got to differentiate. This is just a number. This is a function. Okay, derivative of number times function is number times derivative of the function. Oh, okay, derivative of natural log of function is 1 over your function. Well, if you do 1 divided by your function, well, that's just going to flip this fraction. Okay, so 1 over that stuff will end up being this fraction flipped. So 1 plus x squared over x cubed times, chain rule says, derivative of the inner, you're going to have to do quotient rule on that. So low d high minus high d low all over low squared. So low times d high minus high d low all over low squared. Then you could do some algebra to clean that up. I'm sure, distribute, multiply the fractions. It's going to clean up somewhat. And use Wolfram to figure out what the simplified answer is. We don't need to necessarily do that in that video here. But that's how I would find y prime for that problem.